The Aptena tribe of ants comprises over 240 species, all of which are obligate symbionts to the fungus they cultivate. Many also have symbiotic relationships with bacteria in the genus Pseudonocardia, which can produce antimicrobial compounds that protect both the ants and their fungal gardens from infection. Ant queens pass on the symbiotic bacteria to their young, who then transmit it to future generations as the colony grows. Many ants in this symbiotic relationship have evolved cuticular crypts, which are pits on the exoskeleton housing Pseudonocardia. Inside those crypts, modified exocrine glands provide secretions that feed the bacteria. In male ants, those bacteria housing structures are reduced or absent. Certain worker castes like those who tend the garden have Pseudonocardia that sometimes cover their entire bodies, while foragers have much less. This correlates to the age of the worker. Young workers start out in the garden and switch to foraging in old age. To pass the bacteria on, workers are usually inoculated within 2 hours of hatching. It is nearly impossible to inoculate an ant past this 2-year period. Inoculation is important for young ants, since their cuticles are less developed and their immune systems are less active, making them more vulnerable to infection. Removing the layer of bacteria, called a biofilm, from the exoskeleton of ants and then exposing them to the entomopathogenic fungus Metarhizium anisopliae results in a 3 times higher mortality rate compared to those of ants with intact biofilms that were exposed to the same fungus. The biofilm provides both antimicrobial compounds and a physical barrier to infection. When a colony's fungal gardens were infected with Escovopsis, a parasitic fungus, the density of bacteria on their exoskeletons increased. Pseudonocardia-positive uninfected controls showed an increase in garden mass compared to controls, suggesting growth-promoting effects of Pseudonocardia that are independent of parasite prevention. During an Escovopsis infection, major workers of Acromyrmex respond by moving to the fungus garden until the outbreak is under control. Up to 20% of an ant's basal metabolism can be devoted to maintaining their bacterial colony. However, in colder, drier climates, there's less risk of parasite pressure, and it's also harder to grow biofilms on the exoskeleton. This likely influenced species that first evolved in those environments, like leafcutter ants, to abandon bacterial symbionts in favor of endogenous chemical controls like phenylacetic acid. To summarize, some fungus-farming ants have evolved a symbiotic relationship with bacteria in the genus Pseudonocardia that protects the ants in their gardens from infection and improves the growth of their gardens. This bacteria is transmitted vertically and is metabolically costly. The amount of bacteria is influenced by worker caste and age. Many species in this mutualism have evolved specialized anatomical traits to better support the bacteria. Some fungus-farming species, like leafcutters, have abandoned this symbiosis because it is harder to maintain in their environment.